Okay, so for the boundary mesh in the 2D case, we have the simple options. And for 3D case, we have to create the OGrid, no question is there. But for 2D case, we can go and we can split the blocking this way from the any edge here. And we can create the boundary mesh in this way. But the problem is that we have the different size of the thickness of the on the both sides, and this may make the mesh different on the both sides of the geometry, and we don't want to do it. So either you can undo and also you can merge the vertices and choose the option propagate merge. This will remove the OGrid or this split from the blocking in this way. And if this was the OGrid, then this have been done in the one step. So now I will go for the creation of the OGrid. So from split block, select these all blocks, these 4 blocks here, and choose the 2 edges at the outlet and inlet, because you don't want to create the OGrid or the extra edge here, and we don't want to have the extra mesh here because the boundary is not developing on the inlet outlet. So we choose these 2 boundaries and click on the apply. So we have created OGrid here, and the size of the thickness of these layers are I think is very high. So I will reduce the size from the edit block command, and for that I will select on the modify OGrid, and the default option is the rescale OGrid. So I will choose the one edge anywhere. This may be this edge, and I will reduce the size of these edges by the half. So I put the offset as a 0.5. This will reduce size of this existing size to the 50%, like this. And now I will define the pre-mesh parameters on these edges. So for boundary layer, I will put the, let's set number of nodes 20, and the sizing 1 is going on this side, the side 1 here. So let's say here I put the distance as a 0.001, and write down distance is a 0.007. So looking at the mesh here, I think that the 0.001 will be good starting here. And later on, when you solve the case in the Fluent, then you can decide about the first cell height, or maybe you can, based on if it's a turbulent flow, then you can, based on the y plus values, you can decide about the first cell height here. But for the rough thing, I think the 0.001 will be enough. And if this is a turbulent case, then you can try this mesh first for this type of the flows and see that how the y plus is coming out. And once you see that the y plus is, let's say it's maybe it's a 10 or 15, then you can go and you can put the one more 0 here and again solve the case, and then check again the y plus in the CFD solver. So anyhow, put the spacing 1 as a 0.001, law is a geometric one, and the ratio is a 1.2. And for the inside, I will put the number of nodes also 20, because here the flow is not very important, and the almost gradient is a constant throughout this region, and the highest gradient we will get is in the boundary region here, and especially in the band area. So you must define the mesh in these areas. So here I put the number of nodes 40, and also here 40, because the flow is very with a very high change in the flow properties along this curvature. So you should put the more points here, and the less number of nodes in the straight part, less than 20 nodes will be enough here. And depending on length of this part, I think we should go with the 40 nodes. So it's just initial sizing, and based on my experience, I think this sizing is good enough for the starting point. And then based on your CFD results, you can go for maybe more refinement, or maybe depending on if the mesh is too fine here, then you can coarsen the mesh in the next step and make them solid. So here we have the sizing here is small here, and here we the larger sizing. So we want to keep them same on this change in the geometry as well as in the blocking. So at the change of especially at the change of the high curvatures along the geometry, the cell size should be same across these curvatures. And secondly, when we have the block change, there also we should have the same size change across the blocks. So here we have the first cell height is we taken from this edge, and now put the ratio as 1.2 and apply. And since this is going into spacing 1, so this is side number 1 here, and I will keep the bigeometric here. You can go for also for the, let's say, for the geometric one. And as I see here that from the distribution of the mesh, I can see that the distribution is almost uniform after this part. So let's say number of nodes I will put here 30 and apply. And similarly for the bottom side, I will copy the parameters from these curvatures and then copy them to the vertical edge. And I will apply again the same strategy here. And this is going into spacing 2. This is side number 2 here, that's why. And arrow also pointing towards this side. This is side number 2. This is side number 1. And the ratio I'm putting is a 1.2. And apply. And right click on the pre-mesh and recompute. And hide the edges so that we can have the proper appreciation of the mesh here. And also mesh inside the boundary is very refined here. So this is now we are ready to go for the export mesh, and I think this mesh is more than enough, and you can try it, and maybe you can refine the mesh little bit, or maybe by the factor of 1.414 in the x and also in the y, and see the results yourself and decide on the number of nodes based on your CFD simulations. And let me check the number of nodes in the pre-mesh right now, because we didn't convert the mesh to instrument mesh here, so we don't have the mesh info here, which you can see from the info and the mesh info. So right now we have only pre-mesh, so you can right click on the pre-mesh and check on the pre-mesh info. So number of nodes are 7366 and the number of cores are the 7182. The next video I will export the mesh and read into the Fluent and check the mesh quality.